So today we'll talk about software function oriented software design. So part of this, first we will go into what is function oriented design, and then we will see structured analysis and design, and then we'll see data flow diagrams, and we'll see some examples, and then we'll end up. So what is a function oriented technique? So usually they are very popular in software industry. They are currently used in all software development organizations. Whenever we talk about any function oriented technique, so it all starts with the functional requirements specified in the SRS document. I mean, it all starts from the SRS document, right? Once your SRS is ready, then only we'll be entering to this phase, right? So during that usually during the design process, what we are trying to do, so usually whatever the high level functions that we have identified as part of your SRS document, right? They are part of SRS document, and these high level functions are actually successfully we try to decompose them into very fine levels or into very more detailed functions, right? And these after decomposing these all high level functions into detailed functions, thereafter we try to map these detailed functions to a module structure. Okay, that means ultimately we are coming to a module structure, right? So where you will be going to see different modules of the system. So usually we follow sometime top-down approach, right? So we start with a large problem. I mean, we start with the very high-level functions, and then keep on successfully decomposing them to smaller units of functions, right? So that is the reason why it is all called as top-down decomposition approach we follow. So it has essentially a certain number of important features as part of these object function oriented methodologies, design methodologies, right? So today if you wanted to later on, if you wanted to add any of these methodologies, specific design methodologies to this, so you can easily add. That is what the main advantages of this structured analysis and design. So these techniques, whatever we are going to talk about, the software analysis and design technique, so usually they are completely, based on some of these following methodologies, right? One of the methodologies is Constantine and Jordan's methodology, and there is a Hartley and Peribai's methodology. I told you before also, maybe prior to my lecture. So there are certainly there are the methodologies based upon which these software analysis and design technique are. So now, so usually so these through these techniques, what we try to do, we use it to perform some high level design. Okay, so part of the software analysis and software design methodology, so usually we see these are the two important activities. So the first one is structured analysis and structured design. Okay, main objective of this structured analysis is to decompose the high level function into smaller into further sub functions, or you successfully trying to decompose these all larger functions into a small unit of functions, right? So that is what we do part of structured analysis. And during structured analysis, what we are trying to do is we are actually, once these functions are ready, I mean small units of functions are ready, now we try to map them into a module structure. And now the module structure is actually formed as part of structured design. So this is what, so these are the way that structured analysis and structured design can be broadly um, uh, you can differentiate. So you know this. So usually, we try to decompose the larger function as part of functional decomposition, right, into smaller, detailed, functions, right. And once you have obtained these, smaller unit of functions, the probably, you can easily define what sort of uh, data on which these functions are going to act. Okay, so those things also can be defined. So now, so as I told you, so part of structured analysis, so what we try to do, so usually, after going through the textual problem descriptions, okay, that is part of your SRS, okay, so as part of SRS, what do you do? So you try to describe all of your problems using some natural language, right? Now this will be converted into some sort of graphical model. Okay, so that is what we call as the data flow diagram. So these DFDs are actually, um, they are actually coming out from this structured analysis. Okay, this is one of the deliverable from this structured analysis phase or the activity. So now we'll talk about that DFD soon after this these basic slides. Okay. So all the functions represented in the DFD map to a module structure. So as part of, once you have created the DFD from the text, textual description of your problem. So now these functions will be mapped to a module structure. That is what we call as software architecture. Okay, so as part of software architecture, we have already discussed about this, right? So certain number of modules are actually defined. Okay. Yes, Iswar, you are going to ask anything?
No.
Okay. Right. So as part of detailed design, what you see exactly, you see the software architecture, right? I mean, whatever the modules that you get, so those modules can be directly implemented by the developers using some conventional programming language. Okay, so this is what is part of detailed design, right? Now we try to differentiate. I mean, we try to see we try to find some difference between structured analysis and structured design. So the purpose of structured analysis is what? So it is usually try to capture the whole, detailed structure of the system as a user views it. Okay, that means whatever the, I mean, it is a user perspective, right? So user can understand, okay, what is the complete structure, okay, of the software or the system that we are going to develop. Okay, whereas, something that comes from the structured design, exactly, it is suitable for implementation using some programming language. That means, so this is what actually meant for the developers. Okay, now the structured analysis is mostly meant for the customers, because they need to understand what is the whole detailed structure of the system they are going to get. Okay, I mean, whether whatever the requirements they, whether they are addressed as part of this complete structure or not. So they need to verify that. So for that reason, so you need a structured analysis, and for the structured design, because this is the very detailed design, detailed design of the system. So where, usually the developers, they, I mean, a programmer is going to implement that particular module using a programming language, right? So this is the way that you can see the difference, right? So the result of structured analysis can be easily understood even by ordinary customers. Okay, so because we will see in the after a few slides, you will see an example of data flow diagram where, you usually try to avoid any computer jargon. Okay, so that means we are not going to use any computer terminologies there. So we completely, so we try to write the things, I mean the function names that you will be going to give. So usually whatever the functions we have, we try to, we try to find, what sort of uh, data will be flowing among these all different functions. Those are will be carried out as part of data flow diagrams, right? Soon we will see that. Okay, before that you need to know here. So the representation, is very simple, and it all uses the terminologies what a customer can easily understand. Okay, so thereby it is only, targets, the customer, because customer need to understand at this point of time, right? So the results of structured analysis can be viewed by customers to check whether it captures all their requirements, right? Whatever the requirements are there, I mean they have, whether those requirements are addressed or not, they need to check, so they can check through this structured analysis only. Okay, so here we'll try to find out certain number of functions, right? And the data, now these function names and data, so you will be giving name to these data and functions in such a way that, the customer can understand. It is not meant actually for the developer. So as part of software structured design, so we try to address, aspects which, a designer or the developer can understand. Okay, but here it is for the customer. So based on principles of top-down decomposition approach, we try to, divide the whole in a larger problem into a smaller problems, right? And then we try to give solution to each and every smaller problems, efficient solutions. That is what we try to do. Right. So here we see, that decomposition is actually, represented using some sort of a data flow diagram, or sometimes we call that diagram as bubble charts. Now, so is part of, the data flow diagram. So what you try to do is, so we try to, show the flow of documents or items, or data items or documents within a particular organization, right? So it's a very popular technique. It is very simple to understand and use also as part of our life, right? It's, so it's a very elegant modeling technique. So that is part of, structured analysis. We'll see that with another example, then you will be able to understand, right? So DFD is a hierarchical graphical model. So it's like some sort of tree structure it follows, or you can think of, later on you will understand. But usually here what we do is, so whatever the functions, top down functions, whatever the functions that you have, so you try to explain through a graphical representation that what sort of data item that will be flowing from one particular function or the process to the other processes within a particular system. Okay, so that is what exactly, represented. So here, so each and every function that will be considered as a processing station. That is what I told you. So, so as part of each and every function, so certain processings will be carried out, right? Each function consumes some input data and produces some output. That means it will take some input and then process that particular input, and it is going to give you some output, right? So now, and this is what exactly is part of DFD, right? So you try to find out different, uh, processes, okay, and each and every process is going to take some data, input data. and it is going to give you some output, right? Now with this example, now you can see here, so there is a, let's say there is a fit engine, okay? So we are actually going to define or a data flow model of a car assembly unit, okay? How a car is assembled, okay, within a in a manufacturing unit. So how you are going to manufacture a particular car, assemble a car, right? So now you can see here there are certain number of functions or the processings carried out, right? So the first processing or the function carried out here is a fit engine. So that means first you need to fit the engine, okay? So in order to fit the engine, first you need to take no, a engine from the engine store. Let's say engine store is the some sort of store or the database, so where there are certain number of engines are available. Now you can think of like this, okay? So there is a store, okay? So from where you need to take the engine, okay, and you need to take a chassis, okay, and then you need to fit them, okay? That means here what are the input? One is a chassis, the other one is a engine. So now, so engine processing function, what it does, so it will does something, that means it will combine this engine and chassis and together, and then the output will be coming as a chassis with engine, right? Now this is input to the other function. Now the other function here is processing function here is fitting the doors of the car, right? So now so in order to fit the door, so you need to take doors from somewhere, right? So maybe it is available in a door store, okay? So from there you will be taking this door, okay, and then chassis with engine. So now these two are the input to this processing function. Now ultimately what you are going to get is a very partly assembled car, right? So you have an engine, you have a chassis, now you have doors added onto that particular partially developed system, right? Now the next processing function is fitting the wheels, okay? You try to fit the wheels, okay? So you need to take wheels from the wheel store, right? So after taking the wheels and the partly assembled car, now these two things are input to this processing function. Now what you are going to get is a assembled car, right? So now the other processing here is once you got the assembled car, now that is a input to the other processing function here, okay, or the function. So here this function what it does, so whatever the car it comes as a input, so now this processing function carry out certain processing. That means so it will paint the car and then it will test the car, and then ultimately what we are going to see is a car output, right? So this is what a assembling of a particular car is carried out, right? So I mean we have we have seen through a data flow diagram. That means there are certain number of processing functions, and among them, I mean between these processing functions, some data is actually being exchanged, okay? This is what I told you. Now here you see in this diagram, so whatever the words are used, so it is not using any computer jargon, okay? I mean computer terminologies are not being used, okay? So what we have used here is very simple English, okay, and what easily a customer can understand, okay? So you should not be a, it is not necessarily you be a mechanical engineer to understand this, okay? You just be a customer for that particular car. You going to buy a car, so I mean you want a car, right? So usually you will be giving your specifications like this something. So you want an engine, you want a door, you want certain number of things that looks this sort of, maybe you want some sort of color, right? So that is what you are interested in, right? You are not interested in something in very detailed technical things, right? So that is the reason why it is all going to address the customer's perspective, okay? So ultimately what you are going to see here is a car, right? So this is as part of data flow diagram. Any doubts of our students?
No, sir.
No, sir.
Okay. So right, so is part of any DFD model. So you will see certain types of symbols, okay, and we have certain set of rules, okay, and it follows some sort of hierarchical model as well, okay, because hierarchical models are the ones which will make us understand a complex problem, or which will make us comprehend a very large complex problem, right? So that's the reason why DFD is also using a hierarchical model, okay. So human mind can easily, one example here is human mind can easily understand any hierarchical model. So I mean, that is what in any hierarchical model, we start with very simple and abstract model of a system, okay, and so and details are very slowly introduced when you going from top to the bottom, right? So we start with the, this is what, right? So when I say, maybe your top level, you see the car. Okay, car is the only, large complex problem, right? Further, when you coming down, so you see something like this. First, certain processing will be carried out, right? Large processing, and that particular large processing is again further divided into smaller processings, right? So when you coming down to the smaller units, probably you will understand everything in detail, right? That is what the level of abstraction, okay, is provided by any hierarchical model. This is what exactly I explained you again. I explained you through the previous example. So you can see here, this example also you can see there is a large module A, okay, processing function A, that is further divided into B, C, D, and B is again further divided into certain number of, so it's keep on going, okay, to certain number of levels, right? Now, so this is the way that your human mind also works, okay. So like you have a short-term memory at the first level, and then you have a long-term memory, right? As part of your long-term memory, there are millions and billions of items, but as part of your short-term memory, so you will have to carry at least, maybe up to 7 items, right? Whenever you interact with any of the outside world, right? So maybe those items will not be available all the time. When it is not available, so you go and search in the long term memory, and then you find it, right? So this is what exactly happens, right? So you are as part of short term memory, so you regularly forget them, right? When you going back and then you see again those things, right? You again get back the things, right? Otherwise usually you forget, frequently forget many things, right? This is the way that your memory also works. So you can see now there is a short-term memory is one hierarchy, and another another level that you have long-term memory, right? So every system in this world mostly they work in the hierarchy, so they follow some sort of hierarchical model, right? So that is what we are saying. So the same sort of things we are trying and bringing onto the data flow diagram. That is there in the data flow diagram. So like short-term memory can hold up to 7 items. In software engineering, the number 7 is called as a magic number, right? Yes. So an item is any set of related information. Okay. So you can think of, item means any data item. So that can be a integer, or it can be a mixture of integer character, or it's a word, or it's a story, or it's a picture. So like any related information, set of related information that will be provided as an item, right? Usually so is an information, right? So now you can think of something like this, okay. So whenever you tell something like this, okay, so maybe your Aadhaar card number, okay, so your Aadhaar card number looks like something like this. So it can be, set of numbers, right? Or you can think of maybe your pin code, okay. So or you can see, you always see, right? So now what will happen, so what do we say, whenever you see when you are storing some number 1965, okay, these are the 4 items need to be. So now when you store them, you have stored, let's say your, these are the four different items that require some spaces, right? But you can easily verify, you can easily recognize something. If somebody says is it's your birthday, okay, 1965, you can easily store this. But if I say 1965, maybe it will be very difficult for you to remember, right? Now, so I mean, there is always, modular things works in a better way, right? So, like if you see, so let's say if I somebody says, uh, so if somebody give you very large number, ask you to remember, will you be able to remember? It's quite very difficult, right? If I divide that into very group of numbers, then it is easy for you to remember, right? Maybe you give some sort of idea behind this. Okay, so first four digits maybe your month, a day and month of your date of birth. Okay, the rest four maybe year of four digits, maybe year of birth, and the first two maybe some other number. Okay, you can say maybe current age. Okay, what is your current age and all, right? So now if something is given in this way, so you can easily understand, right? So this is what any human mind also work. So right. So similarly, we try to bring this sort of concepts onto the your data flow diagrams also, right? So now, as I told you, so as part of these data flow diagrams, so there are primitive symbols are used. Okay, so here you can see there is a rectangle, there is a arrow, there is a circle, and there is a two parallel lines, and then you see there is a this sort of shape that you see here, right? Hmm. Now, so you are any external entity. I mean, the entities are the real world, entities or the physical entities. So usually they actually going to input the data to the system, right? Or sometimes these are the entities, they are going to consume some data from the system. Okay, so they can be sometimes called as terminators or source or sink. Okay, so they are the actually external entities. Okay, so now these external entities are represented by the rectangle. Now you can see, and within this rectangle, so you giving the exact name. So now let's say for your library automation system, so one external entity object can be a librarian, because he is the one who is going to input some data into the system, right? As well as whenever any output comes, he is the one who going to take that output, right? Hmm. I mean, someone who is going to interact with the system actually uh, can be called as an external entity. Okay, and these external entities are represented by a rectangle, and sometimes they are called as a terminator, source, sink also. Okay, now let's say for example, as I told you, so as part of data flow diagram, so you will have many functions or the processings, right? Now these functions can be represented by using a circle within which you need to give the function's name or the processing's name. Okay, so now this can be represented through a bubble. Okay, so sometimes these bubbles represent the process. Okay, so here is part of your library automation software. So search book can be one function. It's a high level function. That means you going to a library. I mean, maybe you open the opaque system available in your library, and there first what you try to do is you search the book. I mean, by giving, maybe you input the data like ISBN number or book name or author name, right, or year of publication or maybe publisher's name. So these are the various input that you will be going to give to this function, and after which Now certain processings will be carried out, and thereafter you may be going to see the output. The output will be in the form of something like this. So this particular book is available in the libraries, this rack. You can go and get it, right? So that sort of right information is it is going to give you. That means so you either may be a librarian doing this function, or maybe you as a directly a library member also can be searching this particular can use this particular function, right? So now the external entities can be you as a member or maybe a librarian. So if the system is available with the librarian, so in that case only librarian is going to use that software. But if it is open to every member of the library also, so then librarian as well as you both can interact this particular function directly, right? So now these names are given in such a way that everyone can understand, right? That means a customer can easily understand. So we do not see till any computer jargon or the computer terminology, right? So functions represent some activity. Okay, so usually they are the verbs. I told you very beginning, maybe in a previous lecture also I told you, right, how you can find out certain number of functions that are part of your you know system. So that can be whatever the system functionalities that you want in the system, that will be first converted into some textual descriptions, right? And then you try to find out the compound statements, whether you have any compound statements, right? And part of these compound statements, right, maybe you try to underline the verbs and you try to underline the nouns. So the nouns may be the entities or the objects, okay? Whereas the verbs will represent the functions, okay? So that is already I told you before also, right? So now so a data flow symbol also you have. So usually it is represented through a arrow, and then above which you need to give the what sort of data item actually that will be flowing, okay? So now you can understand this is what exactly a data flow symbol is, okay? So this particular arc is actually carrying some data, okay? Here is data, here is the book name, okay? So that means let's say you are going to input the name of the book to the search method or the search book function, right? So here this is what the data is flowing. From where to where it is flowing? Maybe it is the data will be flowing from a external entity to the function processing, from processing to other processing, or from one function to the other function, okay? This way it works. And your data store, it simply represents a logic, maybe a data structure or a physical file on disk, okay? So where you can store these data, right? So usually in computer terminology, so this is what we call as maybe a logical file, data structure, physical file on disk, but we are not going to write this way, right? So what you are saying is book details, okay? So that data store will be represented this way. So you have a book details, okay, list, okay, from which you taking the data and it is given as an input to the search book method, right? So but actually this in technical terminologies, so it's something like a bookstore, or you can say maybe it's a database, okay? It's a logical file. So each data store is connected to a process, okay, by means of data flow symbol. So that means so from this particular book detail store, so the detail will be fed as an input to the find book or search book method, okay, or search book processing. And your direction can be represented through the arrowhead, that you can understand. So so some data here in this case, some data is read from books and it is given as a input to the or written into the find book method, okay? And whenever you see, so whenever some, so let's say for example, so if you are showing a arrow, that is if it is going from a data store to a processing, usually we do not have, I mean, we do not, try to write or we do not try to annotate this particular arrow with any data name. So it is understood. Okay, it is clearly by default it is understood, right? So books, if I say, so that means you will be giving one of the book as an input. Okay, one book details will be as an input to this method, right? So that's the reason why we do not annotate. But when this is given, that data is actually inputted through a external entity, or maybe from one processing to the other processing, usually we try to annotate that particular arc with the data item. So output produced by the system will be represented through this, okay, symbol. Now, part of this, so you have certain operations, right? So there is a synchronous operation and there is a asynchronous operation. So what is a synchronous operation? So I mean, when two bubbles, no, they are directly connected by a data flow arrow. Okay, so that is, you can see. So now the read numbers is one of the bubble, so it is directly connected to the validate number 0.2. Okay, so these are the two functions. We'll come to this why it is a 0.1 and 0.2, these things, right? As of now, just understand. Now these two bubbles are directly connected, right? So they are directly connected. Whenever you see a direct arrow in between them, so then they are actually synchronous. Okay, that means this particular processing is it's completely dependent on this particular processing. Unless or until a data item is given to this processing, this processing will not start. Okay, that means it is no way going, I mean, it is kept on waiting for this read numbers processing. Okay, right? So this way you can understand, right? Now in as part of asynchronous operations, now you can see, so these are the two bubbles or the processings, they are connected via some data store. Okay, okay, so they are connected via a data store. So something, this particular processing, read numbers, so it outputs some data and it is being stored in the in a number store, and from the number store this particular validate number function is going to take the data, but it is not going to directly take data from the read numbers operation. That is the way that you need to understand. So this is what we call as asynchronous operation. Okay, so whenever, so the two bubbles are asynchronous to each other, so in that case, so they going to use some sort of data store in between these two processings. So as per so Jordan's and Sarson's notation, so they use data star be like this. Okay, two parallel lines and two closed vertical lines. Okay, at the end. So this is also going to represent your data store using this particular notations. I mean, if you are going to use Jordan's and Sarson's notation, so then they might be using this, right? This is the way that you need to understand. So I told you there are 5 different methodologies based upon those which so we exactly use one of them. So sometimes when you search for these data flow diagrams, right, in the internet also, you will find different notations. Okay, you will find different notations, but you make yourself limited to the notations whatever I told you, okay, throughout my lectures, right? So other notations, maybe if you are going through internet and all, probably, because they are developed using different methodologies. So there are 5 methodologies. So they will have their own different notations, right? And it will create confusion to you. Okay, so always check that. Now whatever the notations I told you, so these are the 5 notations I told you, right? Instead of this notation, you should use the 2 parallel lines. That is what uh, it is enough. Okay. So then, how is this structured analysis is performed? How this is performed? Okay, we'll see. So initially represent the software at the most abstract level, that is called as context diagram. So we'll start with the context diagram as part of DFD, right? This is the very basic first diagram, right? So where the entire system is represented as a single bubble, okay? So I mean, so usually this bubble is labeled according to the main function of the system. That means, so it's a very high level, uh, function of that particular system, right? So that is what represented through a context diagram. Okay. So it's a very abstract one, and slowly, we decompose this diagram into different levels. That is what you will see through different levels of this diagram. Okay, the first diagram is something like this. Okay, now you can see, let's say there is a tic-tac-toe. You understand what is a tic-tac-toe and game. So, what will happen as part of this? So you wanted to develop a tic-tac-toe software, right? So the tic-tac-toe software itself is a, it's a high level function, right? That you want, right? So it is so as part of this, so that means whole software, whatever you are going to develop, so that is labeled. That's name of that software. That name of that particular software itself, is labeled with this function name, and then who is a, so I mean, why there is a human player, and the human player is a what sort of entity it is? Can anyone tell me?
External entity.
It's the external entity. So external entity, because he is the one who is going to give his input, right? He is going to give some move, right? Whether the move will be carried out by this particular human player, right? And after that, automatically the software will, that software will, after you giving the move, so it is going to give you, I mean, some display will come, right? Whatever the move you have taken, accordingly the display will come, and that display is again given back to the human player. That means human player is going to see that, right? So that means, so now this external entity so gives some data, okay, as an input to the processing, high level processing. This is what we call as a context diagram. So that means it is the, so level 0 diagram. Sometimes we call this diagram as a level 0 diagram. Okay. So a context diagram shows data input to the system and output data generated by the system and external entity. So as part of your context diagram, you will see these 3 things. Okay. So you are the complete high level functionality of the system. Okay, as a processing function, as a single bubble, and you will see what is the data input that is given to the system, and what are the data that is generated by the system, and what are the external entities. Okay, that means who are actually going to interact with the system. Now here in this case, so you have only one external entity, that is a player. Maybe if you are talking about any other software, maybe there you will have a multiple entities, right? And these multiple entities may be going to interact with the system, right, by giving different data items. Okay, I mean data items as an input to the system, right? So all of the things should be identified as part of context diagram. Now sometimes it is called as a level 0 diagram. Okay, so So it establishes the context of the system, and there are data sources and data sinks. That means so some external entities going to give data as an input. Because of that, so there are the data sources. So the and external entities, they represent data sources as well as they represent data sink also, because they are going to consume some data from the system. That means they are going to take data from the system. Okay, so that is the reason why these entities will play as a source as well as sink. Now, then we need to have a level 1 DFD. Okay, first is a very context diagram, or the level 0 diagram. I told you level 0 DFD. Now, as part of level 1 DFD, so we try to examine the SRS document. Okay, so then now onwards, what you do? So now onwards, we will try to go into the SRS document, and you will see that what are the different high level functionalities that we identified. Okay, and what input data really required for to be as a input to those high level functions, and what data is going to come out of these high level functions as a output. So those things will be studied first. Okay, so that is what we try to do as part of higher level DFDs, right? So now if it is going to again level 2, level 2 DFDs, so in that case, so further you try to identify what are the sub functions of those high level functions you identified. Okay, and then what are the data inputs to those sub functions. Okay, and what are the output from those sub functions. So these are actually represented using DFDs. Okay, so now the decomposition of a bubble is also called as factoring or exploding. Sometimes you divide this one bubble into different sub bubbles, right? So that is what we call as sometimes factoring or exploding, right? So each bubble is decomposed to 3 to 7 bubbles. So as per the experience, it is said that so it is a good number that 3 to 7, right? You can always have 3 to 7 number of bubbles whenever you are going to decompose any bubble, right? But lesser than that and more than that, actually they are not okay as of now. So too few bubbles make decomposition superfluous. Okay, that means I mean, you can think of if you have 1 or 2 bubbles, usually what it means, that means you are actually not dividing anything, right? I mean, so usually the decomposition, whatever you see, is maybe redundant. So most of the things will be, you have some many activities, or many of the processing will have some intersections, right? That means you have common activities or the processings as part of these two divided processings. There is a chances, right? So if you have more than two, so usually, you can think of like this is a large processing and you need a division, right? So and you are dividing it, so that looks useful. But if something that is not really required to divide, but you are dividing it just to divide it, okay, so that's not good. Okay, and too many bubbles, so at any level of DFD make the DFD model very hard to understand, right? So if you're going to divide a bubble into more than 10 bubbles, 10 bubbles or 15 bubbles, in that case what will happen? So actually I mean, it will be very difficult for us to understand. Okay, because so somebody, let's say for example, you have a one at the top level, you have a one bubble, right? Instead of you going through hierarchy, you can have 25 bubbles. You can divide it, that one bubble into 25 bubbles. That means that can be possible, but what will happen? So actually, whatever we are interested in the abstract level, so that is not going to maintain. Okay, so if you can divide that bubble into 5 to 7 greater activities. Okay, and then those activities, if we can further divide into few bubbles, maybe 5 to 6, okay, of 3 to 4, and further those, if you keep on doing this, then we maintain the abstraction level, right? And it will be easy for us to understand at any point of time. So then how long you decompose this? Okay, so so you keep on decomposing these bubbles, a level at which the function of bubble can be described using simple algorithm. That is what we can say, right? So I mean, you going to a bubble where you can, for each and every bubble, you can provide a simple algorithm, right? Maybe I told you, right? So you will be going to a level where you can say that you require a quick sort. So that means you have an algorithm for that. Okay, and or any other task. Okay, not only sorting. So for our understanding, so I always take the sorting as an example, because you know that algorithm for the sorting, right? Right. So that is what I say. So now we'll take an example of this RMS one software, and we try to develop the DFD diagram for this, and then we'll conclude. Okay, today we'll stop. So now here we try to calculate RMS, means it's a root mean square. Okay, we are going to develop a software which can calculate this root mean square of some value. Okay. So now the software first going to read three integers in the range -1000 and +1000. Okay, so in between it is going to read three different integers. Okay, and then we try to find out the root mean square of three input numbers, and then we are going to display the results. You understand? So if there are A, B, C, so what we are going to calculate, if these are the three inputs, so we wanted to calculate square root of A square plus B square plus C square. So this is what we are going to calculate, right? Now for this particular function, how you trying to divide that into sub bubbles and all at different levels of DFDs. So that is what we are going to see. Okay, so at the context diagram level, so what do you see? So usually you want a RMS calculating software, okay, which can take three inputs, okay, which can take three inputs, and it is going to give the output, right? So that is the reason why you can see this diagram. Okay, so what do you calculate? You compute RMS. So that is the reason why its value is, and we level with the 0 because it starts with the 0 level. Okay, and what is who is the what is the external activity here? External entity here, the external entity is user, because user is one who is going to give input to the RMS software, right? So so user will going to give you three data items. Okay, and that is as a data items will be as a input to the system, and what the system is going to give you, this function, the compute RMS, it is going to give you square root of A square plus B square plus C square. Now at this context diagram level, I told you it is only, you will see only one bubble, right? And this function is the whole function. I mean, it is the main function of the system, what you can say in a high level, right? So you will see external entities and the whatever the data items that is going to given as an input to the system. So those things are represented. So now then you try to need to know is part of this RMS. So you will have certain other number of processings required, right? So now, so first thing is that you can see, so whenever you input any number, you take any number from the user, first you need to check whether that's a valid number or not, because I told you, so the number you, so only it reads the number between -1000 and +1000, right? It is going to take the number between this. So and then you try to calculate the root mean square of the numbers, right? And then it is going to reply. So now we can see as part of this, so it is a level 1 diagram where you can see now whatever the processing is, that is divided into into sub functions. Here the sub functions are like this: read numbers, validate numbers, compute RMS, and then display number, right? So now the data is, those three data items will be given as an input to the read numbers function, point one, right? So now these read numbers is actually taking the data from the user external entities, and it is giving as a input to the validate number function. So that will be represented through 0.2. The first one is 0.1, second one is 0.2. Okay. Now validate number, what it checks? It will check whether it is a number is valid or not. Valid means the number should be between -1000 to +1000. Okay. So if it is a valid number, then it is going to give you to compute RMS function. Okay. Then this RMS function will compute it, and it is going to give to the display, okay, function. And now the display function is going to give as a result, right? So now here you can say if the number is not a valid number, in that case also it is going to display. Okay, what it is going to display? It will display that there is an error. Okay, the input value that you inputted, so it is a error value. So this way, it is going to display to the display function. Now so ultimately the display result through display function, so it is giving the output to the external entities, right? So now that previous function is decomposed into these many number of functions. Okay, so at this level, so you have these many number of functions. Now in the next level, what we try to do? Now we try to decompose further this, compute RMS point 3 function. Okay, so this will be decomposed further in the next slide. So that will be level 2. Okay, so in the level 2, what you see now, compute RMS is divided into further some bubbles, right? So they will be represented with like this: 0.3, 0.1, the first one; 0.3, 0.2 will be the second subfunction; 0.3, 0.3 is the third subfunction. That we are giving numbering to the functions. Okay, so that means it is the second level functions that we are identifying. Now calculate squared sum. So what you try to do? So you take some valid numbers. Okay, and then so first what you do? You calculate a squared sum. Okay, now this squared sum is given as an input to the calculate mean. Okay, because so you want to get something like this. So a square plus b square plus c square by 3 square root of this, that is the root mean square. Okay, that is the root mean square, because you first find the mean of the square values and then you have a square root of that. So that is the root mean square. So now what you doing is, first you calculate the squared sum here, and this squared sum is given to this calculate mean. So the mean function will divide by 3 or something like that, and after that whatever the mean will come, that will be given as a so mean square is given as an input to the calculate root. Now root is going to calculate for finally the root mean square. Okay, so this is now you can further squared sum can be divided like this. So because you wanted to calculate a square plus b square plus c square, okay, you wanted to do that. So now that can be 0.3, 0.1. So 0.3, 0.3.1 is divided into certain number, right? So now you can see 0.03, 0.1, 0.3.1.2, 0.3.1.3. So now these are the different processings. So the first processing is going to take input A, B, third one is C. Now the first processing function, what it calculates? It will calculate A square, this will calculate B square, and this will calculate C square. Now these A square, B square, C square are given as an input to the sum function. Now this sum function will calculate what? So it is a squared sum. So A square plus B square plus C square will be calculated. Now you can see. So we still going to a level of abstractions. Okay, right? So we'll stop here at this point of time. Okay. So any doubts of our students?
No, sir.
Okay. So I stop the recording.